Hello and welcome to another ISS video tutorial. We are going to take a brief look at phasor plots and go over a few basic features of the phasor plot on ISS VistaVision, an intuitive measurement and analysis software for everything in fluorescence fluctuation spectroscopy. The ISS phasor plot in VistaVision is a graphical representation of all the raw film data. Each pixel in the image is mapped to the phasor plots at a specific coordinate called the phasor point, which gives us lifetime information of the pixel. The advantages are you do not need to guess the number of exponentials or estimate the lifetime to fit it. You don't need to be an expert in physical and mathematical modeling, as it is a model-free approach, which provides an unbiased way for data analysis. You can go to the ISS website for an in-depth mathematical description of the phasor plot with application examples. Let us quickly take a look at how to read the data on a phasor plot. Single exponentials stay on the semicircle. Longer lifetimes move counterclockwise, so short lifetimes move clockwise. And finally, a complex lifetime species will be inside the semicircle on a linear path between the two contributing lifetimes. So again, the phasor plot offers a lot of advantages, such as easily identify any single lifetime species, visually distinguish between single and multi-lifetime, easily fit complex lifetimes, and finally plot as many images as you want in one phasor plot. So let's head over to the software and take a look at the phasor plots in action. First off, open the phasor plot analysis window by clicking Multi-Image Phasor Analysis in the Analysis pull-down menu. The left side of the window is where we load the film images. The top right side has the phasor plot, and the bottom has a lot of useful tools that we will explore shortly. Let us start by adding images into the phasor analysis window. We are going to add one image to start with. As we load the image, the phasor space is populated with all the points on this image. The threshold function lets you select the point range. We also have a range of smoothing filters available. Let us select median filter and apply smoothing. As you can see, the phasor plot is already populated with 20 MHz lifetime markers. It is clear that we have at least 3 different lifetimes. You can create and add your own markers and assign each one an individual color. You can save the markers for future reference as a new list too. The Cursor tab gives us the option to add multiple cursors. You can move this cursor around and notice the values change. Add multiple cursors and assign each one an individual color and also change their size. Selecting Highlight Image highlights the corresponding lifetime areas on the image with the color of their cursor. We can adjust the threshold again to better visualize the lifetime distribution inside the cell. You can easily export the graph as a bitmap or image file for presentation and save the film image as well. You can add multiple images and group and analyze as well as compare them. For example, let us add 2 more images from a completely different dataset. Now, the phasor space is also populated with the new lifetime distribution. Let us check out file groups. It is easy to batch images and create new groups. All images in the same group can be analyzed at the same time. You can rename the groups as well. Let us rename the two groups as cell and NADH. If we go to group operations, we have two options now, NADH and cell. Let us analyze the NADH group. This way, we analyze both images at the same time. We go to cursors and add a new one for the dataset. When we click Highlight Image, it is easy to visualize the lifetime distribution. You can also set the contrast on individual images by selecting Image Palette and assigning the contrast using the threshold bar. As we saw, the phasor plots are very convenient for data analysis. You can easily compare images and analyze multiple image files in the same group at the same time. Please visit ISS.com for more details.